All right, this is the radical practice part 2. So let's go ahead and get started. So for number 1, we have 3x multiplied by a standard radical that has 9x to the 4th power underneath. So we are going to deal with the radical first, and then we'll deal with the 3x. So what do? You just ignore the 3x and you solve the radical. It's a power 2 radical, right? That's what simple radicals are. And just make everything into a power 2. 9 can be written as 3 squared, because it's 3 times 3. And the x to the 4, we can break it down into 2x to the 2's. Now you can simply cancel everything with the radical, leaving you with just 3x times whatever came out of the radical, which is 3 times x times x. And that is 3x times 3x squared, because this is what came out of the radical, right? Right here. And that is 9x to the 3rd power. So that's number 1. For number 2, you have 4y to the 2nd power multiplied by another simple radical that has 4y to the 6th power. So again, ignore the 4y to the 2nd power for now. We're going to deal with the radical. So first, deal with the radical. It's a power 2 radical, so we're going to turn everything inside into a power 2 if possible. 4 can be written as 2 times 2, or 2 squared. And the y, I'm going to the 6, I'm going to split it 3 ways into 3y to the 2's. Now remember, again, because it's a simple radical, I can now cancel everything that's a power 2. So now I just have myself the 4y to the 2nd power, and from that radical, I'm going to get myself 2 times y times y times y, right? That's what I get out of the radical, which is 2y to the 3rd power. And I just multiply those across. 4 times 2 is 6, and y2 and y3 adds up to y to the 5th power. So that's number 1 and 2. Pause that if you need to. Let me know if you have any questions. And let's go ahead and move on to number 3. So you have 2x to the 3rd power being multiplied by a power 3 radical that has 27x to the 6th. Just like before, ignore the thing outside the radical, and let's go ahead and deal with the radical itself. So it's a power 3 radical, so to solve it or to cancel it, I need everything inside to be a power 3 as well if possible. And the 27, I can write that as 3 times 3 times 3, or 3 to the 3rd power. And the x to the 6, I can split it into 2x to the 3's. This allows me to cancel everything out, leaving me with 3 times x, which is 3x to the 2nd power. Now when you multiply these two, you're going to get a final answer of 2 times 3 is 6, and x to the 3 times x to the 2, that's x to the 5th power, because you add the exponents. The base is the same. That's number 3. Let's go ahead and work out number 4. You have 12m to the 3rd power times a power 4 radical. Underneath you have 16m to the 8 and w to the 4. So again, I'm going to ignore what's outside, and we'll deal with the radical. So I'll still write it, but I'm just going to ignore it for a little bit. Now, to solve this power 4 radical, everything underneath has to be power 4 to cancel out. Well, remember, 16 can be written as 4 times 4, right? And each of those 4 can be written as 2 times 2. So at the end, that's 2 times 2 times 2 times 2, so 2 to the 4th power. And then the m to the 8, I'm going to split it into 2m to the 4's. And I still have that w to the 4th power. So now cancel everything that's a 4th power. So now I just have 12m to the 3rd times 2 times m times w. So I have 12m to the 3rd times 2m to the 2nd w. Multiply it across. You get 12 times 2, which is 24. m to the 3 and m to the 2 adds up to m to the 5 power, and then just a w sticks around. So that's number 4. Let me know if you have any questions on those. Pause this if you need to. Let's move on to number 5. With number 5, we have, I believe, the partial cancellations here. You're not going to be able to fully cancel out the radical, but you can do a partial cancellation, get some stuff out of the radical. So remember, a simple radical is a power 2 radical, which means ideally everything has to be power 2. Here it's not going to work out, but we'll see what we can do. So 8 can be written as 4 times 2, and the 4 is 2 times 2. So it can be written as 2 times 2 times 2. Or I can write it as 2 to the 2nd power times 2. The x to the 3rd, I can split it in a similar fashion into x to the 2nd times just an x. And the y, I can split into y to the 2nd, the y to the 2nd times y, because 2 plus 2 plus 1 is 5. Why did I do this? This gets me the maximum number of power 2's that I can cancel out. I can cancel this, 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 and this. You know, quite a bit, more than half. Which means everything that got their power canceled is allowed to leave. The 2, the x, the y, and the other y gets to leave. And everything that did not get canceled or did not have a power to cancel gets to stay. So this 2, this x, and this y gets to stay. So your final answer is 2x y to the 2nd, and underneath the radical you have 2xy, and that is the answer to number 5. For number 6, you have yourself a power 3 radical, and you have 16 x to the 4th, m to the 5th, and w to the 7th. All right. Again, we're going to try to see what we can do here for a partial cancellation. The 16, I can write it as 4 times 4, or I can write it as 2 times 8. And the 8 is 2 times 4, which is 2 times 2. So I can write it as 8 times 2, but the 8, I'm going to write it as 2 to the 3rd power. So 2 to the 3rd power times 2. That's 16, but it gives me that power 3 that I can cancel. The x to the 4, I'm going to split it into 3 and 1. The m to the 5, I'm going to split that into a 3 and a 2. And the w to the 7, I'm going to split that into a 3, another 3, and a 1. Now everything that's a power 3 gets to leave. This, 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 and this gets to leave. Boom, 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 boom. So what gets to leave? The 2, the x, the m, and the 2 w's. I'm just going to write out w to the 2nd power because it's 2 w's. What gets to stay underneath the power 3 radical? It's this, 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 and this. The 2, the x, m to the 2nd, and a w. And that's your answer. Seems complicated. Seems like there's a lot of things here, but that is the simplified form. So that's number 5 and 6. Pause this if you need to. Let me know if you have any questions, and let's move on to 7 and 8. Number 7, you have a power 4 radical with 32 w7 y to the 6th, and what can we do here? Well, 32 can be written as 2 times 16, right? And 16 can be written as 4 times 4, which is 2 times 2 and 2 times 2. So I can write this as this times this, or 2 to the 4th power times a 2. The w, I can split it into a 4 and a 3. And the y, I can split into a 4 and a 2, because it's a 6, right? Y to the 6 can be split, the 6 can be split into a 4 and a 2, and the w7 can be split into a 4 and a 3. Because 4 plus 3 is 7, and 4 plus 2 is 6. Now, I can cancel everything that's a power 4. So some things get to leave. This, and this gets to leave. So the 2 w and the y gets to leave. What gets to stay underneath the powerful radical? This, and this. The 2, w3, y to the 2. They don't have enough power to cancel with the powerful radical. They get to stay. So that is the answer to number 7. Let's do number 8. So you have a power 3 radical with 81, w to the 6th, m to the 7th. And again, let's try to do a partial cancellation. 81 can be written as 9 times 9, but also it can be written as 3 times 27. It can. So it's one of the things you can write it as. And the 27 can be written as 3 times 9, and the 9 is 3 times 3. So I can write this as 3 times 3 times 3 times the 3. Or I can write it as 3 to the 3rd power times 3. The w is actually kind of perfect. I can split it exactly evenly into 2 3s, which they're both going to cancel. The m is not so lucky. It gets split into a 4 and a 3. So the 3 will go, but the 4 will stay. All right, let's see what gets to leave. This 3, this w, and this m gets to leave. So these are the leavers. 3, 2 w's, so w to the 2nd, because again, 2 w's and the m. Underneath the power 3 radical, what stays? This and this. So the 3 and m to the... Oh, I'm sorry. I made a mistake. I don't have to split it this way. I can actually split the m to the 4 into another 3 and another m. The 4 can be split into a 3 and a 1, which means this goes, and I now have 2 m's that can take off, which means it's going to be m to the 2nd power, and just 1 m stays behind. There we go. So the only thing that stays behind, let me fix this so it looks a little neater, is the 3 and the m. That's it. That's the answer. So 3 w to the 2nd, m to the 2nd is on the outside, and 3 times m is on the inside of the radical power 3. That's 7 and 8. Let me know if you have any questions, or if you want to pause this, pause this. Now let's move on to the back side, and let's do number 9. With number 9, the rule is simple. If you have 2 radicals that are of the same power, you get to combine them. And in this case, both these radicals are simple radicals power 2, right? It's the same power, which means you can combine them under one radical. Now before this, they were either unsolvable or you have to do like a partial cancellation. Once you combine them though, look, see what happens. You're going to get yourself 6 times 6 is 6 to the 2nd power, and 4 plus 1 for the x is x to the 4. And this will actually fully cancel with this simple radical. The x, I can split it into 2x to the 2's. And again, remember, this is a basic radical. I'm going to stop writing the 2. You'll just have to remember that a simple radical is a power 2 radical. Everything cancels, leaving you with just 6x to the 2nd power as your answer. So that's number 9. Super simple. For number 10, you have yourself a power 3 radical with 3y to the 2nd times another power 3 radical with 9y to the 4. Now again, these are both power 3 radicals, which means you can combine them under one roof, so to speak. And then just multiply them. So what are you going to get? 3 times 3 is 27, y to the 6th. Now I want things that are power 3 to cancel with the power 3 radical. And 27 can be written as 3 to the 3rd power. And the y to the 6th, I can split that into 2y to the 3's. And this way, everything cancels out, leaving you with just 3y to the 2nd power. And that is number 10. Let me know if any of you questions. Pause this if you need to. And we're going to move on to number 11. For 11, you have yourself power 4 radical that has 8x to the 5th and y to the 3rd, and another power 4 radical that has 2x to the 3rd and y underneath. Because these are both power 5 radicals, we can combine them under one roof. And you'll have 8x to the 5, y to the 3, times 2x to the 3rd, y. All right. So when you multiply this all out, you're going to get yourself 8 times 2 is 16. x5 plus x3 is x to the 8. And y3 plus y1 is y to the 4th. The y is already set up. And the 16, I can write it as 4 times 4. And each of those 4s is a 2 times 2. So it's 2 times 2 times 2 times 2, right? The 16 can be written as, I'll just write it down here, as 4 2s, right? So 2 to the 4th power. And then the x to the 8, I'm going to split it in half into 2x to the 4th, and the y is perfect. I don't have to do anything to it. So everything cancels out, leaving you with just two x's, so x to the 2nd, and a single y. And that's the answer to number 11. For number 12, you have yourself 5th power radical with 8m to the 4, w to the 3, times another 5th power radical with 4m to the 6, w to the 2nd. Again, you're allowed to combine these because they're both power 5, so you'll have the 8m4 w3 times 4m6 w2. So multiply everything underneath. 8 times 4 is 32. M4 and M6, that's m to the 10th power, and W3 and W2, that is W to the 5th power. All right, the 32 can be written as 2 times 16, and the 16 is 2 times 8, and the 8 is 2 times 4, and the 4 is 2 times 2. At the end, you're going to have 5 2's. So it's going to be 2 to the 5th power. So 2 to the 5th power. The m to the 10, I can split that into 2m to the 5's. And the w is already perfect. So everything cancels out, leaving us with just 2m to the 2nd power, because there's 2 m's that come out and just 1 w. And that is your answer for number 12. So that's 11 and 12. Pause this if you need to. Let me know if you have any questions. And we're going to move on to number 13. Here, these are slightly more complicated problems. You have 2 parentheses, and in both cases, there's something outside the parentheses. So how do you work with these? Remember, you can multiply in whatever order you want. So first of all, I have 2 things outside the parenthesis. I'm just going to multiply those by each other, so 3 times 2. And then I have 2 parentheses that are the same power. I'm going to combine those. So it's going to be 9x to the 2nd, y to the 5 times the 3x to the 4, y to the 4. Perfect. Okay, all right. So 3 times 2, that's 6 on the outside. And with the parenthesis, I have 9 times 3, which is 27. X to the 2nd and x to the 4th, that's x to the 6th. Y to the 5 times y to the 4, that's y to the 9. All right, I'm going to leave that 6 alone. And underneath, we want everything to be power 3. Well, 27, if you remember, can be written as 3 times 3 times 3, or 3 to the 3rd power. The x to the 6th, I'm going to split it in half into 2x to the 3's. And the y to the 9, I'm going to split it 3 ways into 3y to the 3's. So everything gets split here. So what are you left with? You're left with 6 on the outside, and then coming out is a 3x to the second because 2x's come out, and y to the third because 3y's come out. For the last step, multiply 6 times 3, and you're going to get 18x to the second, y to the third. And that is the answer to number 13. Let me know if you have any questions, and pause this if you need to. We're about to go 14. All right. Here you have 5 multiplied by a simple radical. Underneath the radical, you have 8m to the 3, w to the 5, and then multiplied by a 7, which is being multiplied by yet another simple radical with 2mw. All right, again, you can multiply whatever's outside because, again, you can multiply in whatever order, and then you can combine the radicals. They're both power 2 radicals, right? So you'll have under that new radical, one single one, your combined might of the 2 problems. Okay, so 5 times 7, that is 35. And underneath this new radical, you now have 16m to the 4 and w to the 6, because 8 times 2 is 16, m3 and m1, that's 4m's, and w5 and w, that's 6w's. All right, what can we do here? Well, 16 can be written as 4 times 4, and that's what we want, 4 to the second power. So let's do that. So it's going to be 35 times 4 to the second power. The m, I'm going to split it in half into m2 and m2. And the w, I'm going to split it 3 ways. So everything gets to cancel because everything is power 2. So what are you left with? 35 times 4, 2m's, so m to the second, and 3w, so w to the third. For the last step, just multiply 35 times 4, which is 140, m to the second, w to the third. And that is the answer to number 14. Let me know if you have any questions. Pause this if you need to. I'm going to step on to our very last problem, 15. All right, here you have 2x, power 3, radical, underneath 9x, y to the second. Here you have 4x to the second, and underneath you have, next to it you have a radical, power 3, with 9x to the second, y to the second underneath. Again, multiply what's outside, because you can freely multiply things that are outside. So that's going to be 2x times 4x to the second. And combine the 2 radicals because they're both power 3 radicals. So it'll be the 9xy to the second times 9x2 y2. Really similar problems here. So 2x times 4x squared is going to be 6x to the third power. And underneath our power 3 radical, you're going to have yourself 9 times 9 is 81, x to the third, and y to the fourth. This is actually not going to fully cancel out. You're going to get a partial cancellation because 81 cannot be written as anything to the power 4. But 81 can be written as 3 times 27. And you know that 27 is 3 to the third power. So what I can write this as, I'm going to keep the 6x to the third here just for a second. I'm going to write the 81 as 3 to the third power. That's a really big. 3 to the third power times 3. X to the 3, that's perfect. But the y, I have to split it into a 3 and a 1. Now, everything that's a power 3 can cancel out and leave. So what's going to leave? These are going to leave. So, still have that 6x to the third power. And now, you're going to get yourself a 3, an x, and a y that leave. And underneath this power 3 radical, you have some things that are left behind, this 3 and this y. All right, now go ahead and multiply this, because they're both outside the radical, right? So that's going to be 6 times 3 is 18, x3 and that 1x, that's x to the 4, and the y just tags along, and you still have whatever you had, underneath that power 3 radical, which is the 3y. And that is the full answer. I know it's a big problem. That's like the most challenging problem in this worksheet. All right, let me know if you have any questions. Pause this if you need to, and thank you.